talking about energy. And the interesting thing is, 4 years earlier, September, the same crowd. So how many people were there in the 2010 talk? New crowd, but hopefully, I mean, the key is those 3 people. Hopefully, it won't be the same crowd. So I'm going to give you a quick perspective on energy in India, and I've been asked to do this to sort of set the context for the discussion in the panel. And of course, we are fortunate to have Harish here, so he will add much more in his own perspective, which is nice. So I'm going to quickly go over energy in India, a perspective. Before we do that, start with a sort of overall global perspective. And you know, to the best of our knowledge, the Earth is the only planet where there is time. The best of our knowledge, that's true. And if you look at a sort of time series of the temperature, the reason for that is because we have relatively stable temperature. The average temperature of the Earth is about 15.5 degrees centigrade. The land and the water. And if you see this, you know, there has always been a fluctuation. Okay, so basically it's the last couple of 1,000 years is where we've had relatively stable temperatures, and this is the Holocene, which is where we had human beings coming on, and the interesting thing is, the very fact of us having these stable temperatures and then developing, and then we are moving to, people say that maybe we are now talking about the Anthropocene, where we are creating our own reality, and that has its own kind of problems. For instance, if you look at this, look at any parameter, you start with population, you look at GDP, you look at damming of rivers, water use, paper consumption, steel, cement, all have very unhealthy exponential growth. From a business point of view, very healthy. But overall, exponential growth trends, okay? So just look at that, and you can add on now McDonald's restaurants or anything. You see, these are actually time series trends, very nice exponential growth trends, which means area under the curve is unbounded, right? And the question is, when you have these kind of growths, the question is, can the ecosystem, can the earth actually sustain those growths? And there's an interesting paper in, so the question that we ask ourselves is, our present consumption and growth pattern sustainable? Can we continue this into the future? And like any way you look at this, in the present form, our consumption patterns are not sustainable into the long term, and we need to make modifications. Just to give you one simple illustration to show this, we talk of, basically, you look at this in the paper in Nature, where you look at what are the planetary boundaries, and for each of the different things, where you look at ocean acidification, chemical pollution, climate change, biodiversity loss, land system change, based on historical trends, natural baselines, and the Earth's capability to withstand, to sort of regenerate itself, this paper established certain norms and boundaries. And on a set of different points, you can see climate change, which has exceeded those boundaries, the nitrogen cycle, rate of biodiversity. So what happens is, we start with the philosophical belief that the earth is there for us and we grow and we keep using things, and then as we do that, we come up with some barriers because there are some unwanted, undesirable impacts of that growth, and then we identify a problem. problem with the ozone layer, we fixed it by changing the CFC. Now we have a problem with climate change. And so that means that, for instance, the climate change problem, I'm sure many of you are familiar with this. You just look at a time series trend of CO2 in the atmosphere, and you find that in the over the last 1,000 years, about the first 800 years, the planet was under a natural equilibrium. There's a fluctuation, but it's all around 280 parts per million by volume. And we have this by basically looking at ice core, where you have the frozen record, and that's how you've got these. You just go to the web and you find a large number of such trends. And then what happens? We have the industrial revolution, and you have the second trend, which is almost completely different from this trend. It's an exponential growth trend, as we saw in any of the other trends, and which means that now in this, given the fact that we are talking of CO2 affecting, being a key gas for the radiative forcing and affecting the temperatures, we expect this will lead to the rise in the temperatures, which will lead to sea level rise, lead to all kinds of impacts on the climate. And the point is that this is definitely not sustainable. So you look at how do you define sustainable development, and this was given in the Brundtland report. Basically, development that meets the needs of the present without compromising the ability of future generations to meet their own needs, and so that future people will enjoy at least the same quality of life that we enjoy today. And typically someone has said development without cheating our children and grandchildren. Typically we are all selfish. So we can only think of something in our lifetime, something with our own children and grandchildren. So it's for 50 to 100 years. Anything beyond that, no one even 50 to 100 years is like long term. So this is what we look at. So this is sort of setting the key. And so if you look at, you can look at the carbon footprint. So if you say so much CO2 is going out, you can put all the different countries, and you can see, of course, India having a much lower CO2 emissions than the global average, and you have US and others. But if you look at even the Indian context, there's a Greenpeace report called Hiding Behind the Code. So within the country, we have a whole host of different segments of population. So some of us are more near this kind of trend, and then there are some who are even below, and that's how we get this kind of categories. So you can of course calculate your carbon footprint calculator, and you can do all the calculations in terms of how much electricity you use, what you use for your cooking fuel, and then how much you use for travel. But one simple thing which you can see, that your CO2 emissions will be directly proportional to your frequent flyer miles. You can try this out. You can put your numbers and you can see. So certain things are. So now let's go back. So that's sort of setting a sort of global context. But let's look at what does it mean for India. So in all of this, it's always best to first start from basic principles. Let's do a Sankey diagram, energy balance diagram for India. So this is currently energy uses pattern. If you see, these units don't bother about the units and all that, but it's about 33 exajoules. 1 exajoule is 10 raised to 18 joules. And just to keep some sense of proportion in mind, the total world consumption is about 550 exajoules. So we are about 6% of the world's energy consumption, primary energy, and we are about 1/6 or 16% of the world's population. So that means we of course we use less energy, and as we develop, we will expect to have more energy services, less will be involved, so that there is a very significant growth in the energy sector. A few points I would like to mention here. One is that a significant part of our energy supply comes from coal, yes, that it does. Also, there is a significant amount of imports. Most of the oil that you see of 9.8 exajoules, a large part of it is imports. Okay, and a large part, even today, a large part of our energy is traditional biomass, mainly used in the residential sector in food source. And so this converts to this in terms of our electricity, it's mostly coal, and you see in the overall mix, you will have this kind of thing. So I can share all these slides. I'll just make sure that. So in terms of a balance, in terms of the primary energy that we use, it's almost apart. There's coal, followed by oil and natural gas. If you look at the world, it would be highest would be oil, followed by coal and natural gas. And of course, you can see the total 24 exajoules in 2007, 33 exajoules. Okay. Yeah.
Commercial energy or actual energy?
Well, you know what happens is that we have a clearer estimation of the commercial energy. The traditional energy is the commercial energy is all computed based on from the balance sheet, so we know those more accurately. For this is an estimate. So the traditional biomass, dung, etc. is included here, but there is a plus minus, there is an uncertainty associated with it. Okay, the other issue that we have is the issue of energy security. And if you look at the share of energy imports, if you take that total energy balance and see what percentage of the energy, primary energy that we use is coming from outside our country, then if you look at that share, you will see that there is a very clear and unhealthy trend. There is just going with it. And now we are thinking of actually having coal imports for our power and all that. So this means that, you know, suddenly one of our friends may decide that we are not, we are a hostile country and shut off a certain source of supply, and then we are sunk. So energy security, most countries, the policy and business activities are to ensure that you have security. Security could mean diversity of sources, it could mean diversification, it could mean having indigenous storage, indigenous capability, so there are a whole host of things. But this is one of the things that we need to keep in mind when we look at India in terms of the energy situation. The other thing is, in terms of primary energy, if you take, let's say today we are in 2014, if I say in the last 30 years, do you think our renewables share has increased or decreased? Do you think we have increased our renewable share in our energy mix? How many think renewables have increased in our mix? Absolutely. In the share? Share must have increased. Interestingly, the share has actually decreased. So if you look at this is a tri-block which we created, which talks of renewables and nuclear. Renewables and nuclear in the 70s was about 60% almost of our total mix. See, there are two trends which are there. One is the trend of going from traditional to modern, which means traditional to fossil. And then within the modern, if you look at modern food, then the renewable share has been increasing. But in an overall sense, hydro share is also renewables, large hydro. That used to be much higher earlier, biomass. And so the question challenge is, as we go back, can we go back on this line with modern renewables? And that's a non-trivial challenge. It's a non-trivial challenge because there are lots and lots of issues. It's easy to say we will replace everything with photovoltaics, but there are issues involved, and we can maybe hopefully in the discussion we can talk about that. In the power sector, if you see, same thing. We were almost like 40% hydro in the days of the large hydro projects, and now we've got over 80% of fossil, and of course it's coming in. So the other interesting thing, Ketab is here in the audience. I didn't know he was going to be here in the audience, but it's Ketab's MTech work. which talks about equality. And this is something which doesn't usually come in this. The inequality in electricity use is higher than the inequality in incomes. And this is a global phenomenon. But so if you look at it, we try to map, if there's a Gini coefficient, you see if it's a completely equal world, you have like a 45-degree line. Completely unequal world, that means no one has anything and one person is a Mukesh Ambani, then you go like this and straight up. Okay, and somewhere in between, and if you see, our inequality has been decreasing, but this is electricity rural and electricity urban, and you can see 25%, 26%. We've taken this from the NSSO survey data, and you can see, and so there is this challenge of creating and providing the access and providing an equal. So if you look at historical household electrification rates across the world, you'll see that everyone has gone to a stage where, even the US, UK, when they've gone to household electrification. If you look at India, this is the status. China suddenly ramped up and electrified, and we are somewhere here. So we have still a lot to do in terms of the rural electrification. Okay, so whenever we talk of access, whenever we talk of energy, we usually, the focus on predominantly is always electricity. But there's a large chunk which is on cooking, and this is also very, very important. More than 50% of the households are still using solid cooking fuels. What is the problem with it? Efficiencies are about 10%. The advantage is relatively low cost for the household, and but high emissions particulates for a long time, and the health impact, respiratory health impact, both for the children and the woman who's cooking. And there's also a gradually collection and cooking time. We made some estimates. The cooking plus collection time for fuel wood and dung can be of the order of about 2,000 hours per year, and if this goes to LPG, that will come down to about 500 hours per year. So that's of course, it's a question of the opportunity value of money and things like that. Of course, there are technologies involved. Technologies are there, but these technologies don't disseminate. And this is an interesting, this is one of our Sitara first PhD students where we looked at heat transfer enhancement, twisted tape inserts, and putting them on the existing chulhas, and then we train blacksmiths, local blacksmiths, and we can get about fuel usage reduction by about 20%. So there are, of course, a large number of technologies, including, you can do modern. This is a California-based startup where you have a BioLite stove, gasifier stove, and then the exhaust gases are passed through a thermoelectric generator, and you can use electricity to put an LED lamp or even charge your cell phone. And people pay actually for the smallest amount for cell phone charging. If you see the amounts that people pay in rural areas, it's very high. If you look at it in terms of rupees per kilowatt hour, it may be something like 15-20 rupees per kilowatt hour. But anyway, so this is another area where there is. So just to quickly summarize whatever I've talked so far, present energy systems predominantly fossil fuel based. They are unsustainable in the long term. Fossil fuel reserves, limited, climate change, and issue environmental impact. Energy access in the Indian context is a key issue, and affordability is a key issue. So we need to look at, finally, when you look at long-term dissemination, what is the cost at which we are going to be able to do this. We have energy shortages which persist, and which are likely to persist in the short term, 5 to 10 years. Low usage, high growth. So transaction costs are an issue. So you can have ICT and other solutions. Energy inequality, very significant issue, not much talked about. Any inequality generally is not talked about. And energy security, again, another issue for the year. So this cartoon from Gilbert, you see Lockwood writing a fake press release for imaginary new green energy technologies. Scientists say by 2040 you'll be able to power your entire home with the breeze from your refrigerator door. So Gilbert asks him now, how will I know which green breakthroughs are real? Seriously, you think there are real ones? These are all made up. So there is one set of skeptics which say that, but the truth is not. Actually, we have a large number of technologies, and just to, we can look at, if you look at all the appliances or the end users related to a house, we can actually look at, I've excluded tidal and marine and others, but whether it's solar, biomass, wind, geothermal, small hydro, either electricity or directly, for any application today, we can configure for you a technology and it will be equally reliable, may not be equally cost effective, and that's the challenge. But it's already there. So these technologies, unlike the cartoon, the technologies do exist. Also, it may be worthwhile to say that we are in renewables. The phase is changed. Initially, we were just at the margins. We are now getting into the mainstream. This is a plot which shows you the renewable installed capacity and the nuclear renewable generation. So 2 points to note. One is that today, this is of course up to 2010, but today modern renewables, excluding large hydro, accounts for about 7% of our total electric generation. That's a significant amount. Just compare it with nuclear, which accounts for about 4%. And just think of what is the infrastructure, the capital investments that the government and others have done for nuclear. And so the other factor you will notice is that there is this gap between renewable installed capacity and generation shares, and that's because renewables has a lower capacity. So just to give you some numbers, of this PV catching up fast, 2,700 I think, as we speak, this is 21/7, 31st 7, and so in 2 months maybe another 200 or 300 maybe. This is all grid connected, large, interactive, and wind is about 21,000, and small hydro again. Small hydro actually has much more potential than realized, and there are reasons for that. Okay, just to give you now, let's look at what does it mean, what is on this cost basis, how do these technologies, these large centralized generation to the grid, how do they compare? So you see, this is from the Bloomberg New Energy Finance Report in 2014, which surveys all the investments in all countries in the world. So if you see on coal and natural gas, there are a whole set of different points because the capital cost depends on the region in which they are. And but you will see that typically we are talking of something between 3 rupees 50 paise per kilowatt hour. This is the 6 rupee and this is the 9 rupee, and you can see very interestingly, you have a 2014 average number and a 2009 number, and for PV you can see the great reduction in the cost. Okay, now we are at about 9 rupees, but earlier you can see. So the question is, of course, some of these things you can get it down, but then it goes asymptotically to some kind of a limit. So it's not necessary that you can just project it and say, okay, grid parity, and please also remember, it's not just a question of rupees per kilowatt hour grid parity, it's also a question of the investments that you make. So for instance, just to look at it, if you talk of let's say, what is it, 9 crores or 7 crores per megawatt, something like that, 7 crores. So 7 crores per megawatt, if you say PV, with a capacity factor of 20%, it means for an equivalent coal-based plant, we are talking of something like 28 crores. So of course this is at a large centralized, but it's quite possible that when we talk of renewables, the paradigm will not be large centralized, and we need to look at a paradigm which is a distributed, decentralized kind of paradigm. Okay, the McKinsey curve, India abatement curve, talking in terms of CO2, we go back to CO2. You see the cost per ton of CO2 saved, and you see a large number of things which are negative. So there are many things where it doesn't cost you anything and you can save CO2. And these are typically efficiency options. So mostly we focus on renewables because there's a investment and there's a market push, and but there's a lot of other things which can also be done. So it's not renewables versus this, it could be both renewables as well as efficiency. So just to give you an idea, if you look at any standard fan and you will see the ratings are of the order of about 70 watts. We We have now in the market fans which are about half that rated, VLDC fans, and the cost is slightly higher. And then this is something where you see it's extremely cost effective. Lights, we've gone from incandescents to CFLs, and we can look at LEDs. Of course, the whole issue is we need to think in terms of innovative financing so that the upfront capital cost gets distributed. And in DSM there was a plan which was made, there was a financing where you continue to pay your electricity bill as if your incandescent was still there for some time, and the electricity company recovers that money and then uses it. And this was the scheme. So the idea was that you would sell CFLs at about 15 rupees. And of course, the unfortunate thing is it went a reasonable way, but the problem was it was based on the taking an additional flow, cash flow for the CERs. That is tons, and that was based on the market, CER market, which crashed. So the numbers good. But the idea, as you see, and of course Harish has many innovative things in terms of how he has structured financing, so we can probably share over this. Well, whatever we say, it makes sense, we should be able to do it in our own place, right? So in the main building, we took some measurements. We thought we should start from the administration director, deputy directors and other rooms. We took measurements of all of this, and we looked at the load profile, and with DSM, this is how the load profile should be modified. And in the case, cost of saved energy was, in all these options that we looked at, was actually less than the cost of supply. Okay, so now the issue of when you go from margins to mainstream, many other issues come up, which often, when you talk of it at the, so for instance in Tamil Nadu, I don't know how many of you are from Tamil Nadu? Okay, so in Tamil Nadu, Tamil Nadu from a renewable point of view is very interesting because it has the largest share of wind installed capacity. And what happens is, you see, this is 2006-2007 data. You can see that most of the wind gets generated in 3 or 4 months. And if you look at the wind generation, you will see in different months, during different hours of the day, the generation is completely different. So we are talking about a few thousand megawatt differences. So if you plan for this in your system, that means when the wind is not there, you need to have some other backup. And that means you have to provide fossil fuel plants to meet the requirement. Those fossil fuel plants have to be backed down so that your wind can continue. And the higher the penetration, the more the problem, because as you increase the penetration, the impact of that wind on the peak becomes actually lower. So this is some of the issues, unless we can do cost-effective storage. That's another story. But this is one of the mainstreaming challenges where you can't just say, we do this and then you have, and one needs to look at things like this. On the other side, if you look at isolated systems, the supply and demand must match. And for instance, so this is like you will have a load factor of about 20-25%. So if you look at our insulated systems, you will have electricity generation prices of 15, 20, 25 rupees, and that's how it sort of works. And so the question is, in this you have to generate methods by which you can have income generation and ability to pay. And one of the things that you could do is if you size a PV system, and at that time you also change the appliances, it's cost effective. Instead of investing just in the PV, you invest in PV plus LED plus efficient fans. And you can see this, we did this illustrative thing for 100 households where you see a peak rating of 18 kilowatts with all the DSM options, that peak rating goes down to 6.6 kilowatts. And the overall, so you increase your investment in appliances, but you reduce your investment in your PV, and overall cost of the system goes down. Chetan will tell you probably more about this. We installed a number of PV modules on our rooftops, typically 70-80 kilowatts. All of it together adds to about a megawatt. We have also been involved in trying a number of new projects in the real world, in the consortia mode. And one of the projects that we have now, we're going to step back, we finished this, the plant is operational. It's a 1 megawatt grid connected solar thermal power system with parabolic and Fresnel reflectors and an integration through a heat exchanger. We built a simulator and a test facility. We are going to hand this over to the ministry early next year. These are the images of the plant. This is the parabolic trough field. There's a power block over there, and on this side we have the linear Fresnel reflector. This is a Sterling. This is the dish, the big Kedaris dish you are testing on this test facility. This is at Walpahari near Gurgaon. We have a simulator which is available for download also. The other thing is, I personally believe that a lot of, in the energy sector, a lot of things will now come through innovations. And the best people suited for doing these innovations are our students. Because unlike us, who are used to looking at things in a different structure and saying this can't be done, this can't be done, students say that, you know, why can't we do it this way? And then they just go ahead and do this. So we have at the institute been encouraging student teams. So there's this electric vehicle team which participates in the Silverstone, that UK competition, and we have Toon Shunya. This is a team of students who were the first Indian team to participate in the solar decathlon, where they built a 680 square foot functional house which was running completely on solar. They built it in the IIT campus, shipped it to Basset. They worked hard, and over 10 days they rebuilt it there, and then finally reworked all the systems, and every single system worked. And the other thing is that the budget of our team was about 10% of the budget of any of the other teams. So they really struggled, but they will talk about their experience. But we are now planning to rebuild this house in the IIT campus as a lab, which anyone can see and we can talk about. So this is the team at the inauguration, and this is the building. Very smart. So, having said that, one of the issues which is going to come in as we go for more renewables is going to be storage. Storage can be at different levels, whether it's at a large central level or at the household level, at the microgrid or in the automobile. And there's a proposal now for a new energy storage center at IIT Bombay. We found that there are about 50 to 20 faculty members across various departments, so they are working out, and with both fundamental research as well as technology development and systems analysis. So I'll quickly sum up now. In terms of a set of priorities, I would say priority should be first energy access and equity, because that's not necessarily the way the funding goes. There is an issue here in terms of capital and development, electrification and clean cooking fuels. We have to figure out in all of this, we have to see how to do this in a way in which it links up with income generation and employment. And all over the world, employment is a key issue. And you cannot just talk of energy or water, and everything is linked with everything else, but employment is key. India, energy shortages and growth, these are the two characteristics. Energy security also. We need to have a paradigm shift where we focus on energy services. Easier said than done, because my electricity supplier would like to sell me more electricity. Similarly, is my oil company. They will not tell me that, okay, I can sell you a retrofit on your air conditioner so that you get the same cooling, but you not use less electricity. Businesses are not structured that way. Even our terminology, we never say longage of supply. We say, longage of demand. We say shortage of supply. So everything is, we need a paradigm shift where we focus on services. Otherwise, the incentive structure, there's a lot of lock-in into certain technology. It's not going to happen. There is there are issues related to system. When you scale some of the options which are being done, there are system integration issues, there are issues of storage, there are issues of load matching. There is an issue of deciding policy independently, and not, of course, most countries in the world policy is of course decided by lobbies, but sometimes some lobbies are stronger than others, and it's not necessarily related. So you need to have some way of assessing mid-course whether what you're doing is right or not. We need to have, there's still a very strong need for technology development, for cost reduction. Just think hybridization, energy efficiency and renewables, and then we need to have consortia and collaboration between academia and industry. Much talked about, but not happening to the extent. It's happening more than earlier, but we need to have a special focus on new stock. For instance, we can just transform our entire energy sector if we can develop cost-effective buildings which generate their own energy. Right? And similarly, industry, we can redesign our products. We can make our industry, if you look at this second law, exergy efficiency of the world industry, it's only 30%. We have done this for the global energy assessment, it's only 30%. We are nowhere near our fundamental limits. There are fundamental as well as technological developments which are possible. So it's we can't talk about energy without talking about land. See, I can do a theoretical calculation and tell you that I can take so much area in Rajasthan and generate the total electricity. I have a map actually, I'm not sure that. I think I showed it in the last time I spoke. Where you can say so much area, and this is so much population density, and it's in Rajasthan with very high insulation. And so it's only so much percentage of India's area, so no problem. Go and try and get that land. I mean, try and get, we built this plant in Gwalpahari because we were in talks with Maharashtra and Gujarat that we were going to get land in Aurangabad. But the ministry said that you show us the land, otherwise we are not going to give you the funding. I can give you land in Gwalpahari. If you want the project and the funding, either you show us the land or you take this. We do that. And it was difficult because firstly that place is not good for insulation. Winter months, the freezing of the oil, we had lots of problems. Anyway, finally we learned a lot of lessons from that. But land is an issue, water is one main, and water and energy are completely connected, and employment. The incubation, innovation ecosystem that we have, I think that is something which I think we need to scale, and that is the energy area can have lots of. I don't think I'll take too much more of your time. I've taken some of the work of some of our students as well as I'll end with a quote saying that you never change things by fighting the existing reality. To change something, build a new model that makes the existing model also. The question is whether we are going to have that new model, or whether we have a combination of different things, or whether we go for incrementalism. All of this is to be seen. But the energy sector has significant challenges and significant opportunities. And I think IIT Bombay alumni and IIT Bombay itself, all of us can really play a role in this.